Hey, this is Mr. James. In this video, we'll be talking about the converse of the transversal theorem. Now, before I get into what that means and how to use it, let me show you when you might use it. Mr. James is having a competition amongst the teachers to determine who can draw the best parallel lines. Create a rule or formula for judging the teacher's lines. Then determine who comes in first, second, third, and fourth place. So here we have four pairs of lines. We'll call these A, this is pair B, C, and pair of lines D. Now we want to figure out which one of these is the most parallel. Now remember, parallel lines are two lines, or pair of lines, that do not intersect. And so one thing we could do is if we just took maybe a ruler or something and continued to draw each of these longer and extended them, then we could figure out if they intersect and how long it would take them to intersect. Ones that intersected more slowly might be closer to parallel, and if they never intersected, well then they'd be perfectly parallel. The issue here is there's not enough paper for me to do that. I'd have to be drawing these lines pretty long and I'd go off the paper and off the camera. So I'm going to show you another thing we can do. Instead, what we can do is we can draw a line like this between the two parallel lines. Remember, this line I've just drawn is called a transversal because it intersects two other lines. Then what we can do is check two of the angles, one on each intersection. For example, this one and this one. Now you'll remember that those are called corresponding angles. Now we know that if these two lines were parallel, then the corresponding angles should be congruent, or the same angle measure. We can also use the converse. If I measured these two corresponding angles and those were congruent, then the lines would be parallel. See how I kind of stated that theorem backwards? Now on the other hand, if I measured these two corresponding angles and they weren't congruent, then these lines would not be parallel. And the farther apart they are, the less close to parallel these would be. So what we can actually do is go ahead and I could draw a line, okay, some sort of transversal, between all of these pairs of parallel lines, just like this, okay? And then I could check, by measuring with my protractor, the angle measure of all of the corresponding angles that I just marked. Now, I'm going to use my protractor for this, and I'll speed this up a little bit. We'll talk when I finish measuring. Now you'll notice I had to extend some of my lines here in pink or blue or purple so that I was able to fit them onto my protractor and measure each of these corresponding angles accurately. But once I had done that, I found that the corresponding angles in A were 101 and 104 degrees for a 3-degree difference. In B, they were both 72 degrees. In C, the corresponding angles were 64 degrees and 68 degrees for a 4-degree difference. And in D, the corresponding angles were 54 degrees and 44 degrees for a 10-degree difference. Now remember, if the corresponding angles are congruent, then the two lines are parallel, which means that B are the only two lines that are perfectly parallel. Okay? So I'd say that this person came in first, right? They drew two perfectly parallel lines. What about the other ones? Well, they're not exactly parallel, but we could probably rate them as to which ones are closer to parallel. I would say that the pair in A came in second because they had a 3-degree difference. The pair in C was a close third with a 4-degree difference. And in D, they were off by quite a bit, a 10-degree difference, so I placed them in fourth. So now it's your turn. For problems 1 through 6, determine if lines M and N are parallel. Below in 1 through 6, I have two lines, M and N, and a transversal for each one. I also have a few measurements on each of those transversals to help you determine whether they're parallel or not. So pause the video and try these on your own. All right, let's start by taking a look at number 1. In number 1, we have these two corresponding angles that are both 42 degrees. Therefore, they're congruent. Now we know if the corresponding angles are congruent, then lines M and N are parallel. So I'd say yes, M is parallel to N. And again, that's because of those corresponding angles. Corresponding angles are congruent. Okay, what about number 2 here? Well, we've got these alternate interior angles. One is 94 degrees, the other is 93. So although they're close, they're not exactly equal. So I'd say no, M is not parallel to N. So the parallel symbol with a little slash through it. And we could say because the alternate interior angles are not parallel, or sorry, not congruent. Again, congruent symbol with a slash through it. We'll do that. What about the third one? Well, the third one's a little tricky. You've got these two vertical angles here that are both 72 degrees. Now we know that vertical angles should be congruent, but actually that doesn't tell us anything about line M. There's nothing on that intersection that's labeled. So we can't actually make any conclusions about N and M. If they had told us that this was 72 degrees, or that this was 72 degrees, then we could have said that M was parallel to N. But without any information about line M, we're stuck. So we can just write, not sure. So in 6, you might be tempted to say that M is not parallel to N because 119 is not equal to 61. But watch out. Perhaps 119 isn't supposed to be equal to 61. It might help to fill in some additional angles here. So I know that vertical angles are always congruent, so I'll put a 61 there, and I'll put 119 here. And in addition, I know that these two angles should be supplementary, which means they'll add to 180. So let's think 180 subtract 61 leaves me with 119. So this angle is actually 119 here, 119 here. And over on this side, well, again, these two angles will be supplementary. So 180 minus 119 is 61. So actually, if you take a look at these, all of the angles that correspond are congruent. 119, 119, 61, 61. Alternatively, you could have also noticed that 119 and 61 were same-side exterior angles, and same-side exterior angles should sum to 180 degrees. 119 plus 61 does in fact equal 180 degrees. So any way you do it, yes, in these, M is parallel to N. Now again in 5, it may be useful to fill in some additional angles here before we make our decision. So again, I'll use vertical angles first, and then I'll look for some supplementary angles like these two right here. Let's see, 180 subtract 85 leaves me with 95 degrees. 95 degrees, and the vertical angle is also 95. And over at the intersection with M, 180 minus 105 leaves me with 75 degrees. So 75 and 75. Now looking at these, the corresponding angles, 75 and 85, those are not congruent. Or you could look at it this way. 105 and 85 are same-side interior angles, so they should sum to 180 degrees, but actually 105 plus 85 gives us 190, not the 180 that we're looking for. So any way you think about it, no, in this one, M is not parallel to N. Lastly, let's look at 6. Now in 6, we've got a 60-degree angle and a 120-degree angle, and those two should be supplementary. And in fact, 120 plus 60 degrees yields 180 degrees, so those are supplementary. Now we could fill in some additional angles, like the vertical angles here and here, but we don't really have any other information about that intersection with N. Now, had they have told us this was 60 degrees, we could say they were parallel, but we can't just fill that in right now because we don't know they're parallel. That's what we're trying to prove. And since there's no other information about any of these angles intersecting with N, in fact, we have to leave this as not sure. Now you're going to finish this truly on your own. For problems 7 through 10, determine which two lines in each figure are parallel. So in 7, we have a number of lines H, G, K, and J, all with this transversal M. Now to do this, try and fill in some additional angles on each intersection to help you understand if any of those corresponding angles are truly congruent, and if they are, those are the lines that are parallel. Remember, don't just take one of the angles and copy it down over here, because we don't know if the lines are parallel. If they were parallel, we could do that, but we're not sure yet. So just use each of the intersections separately, using your vertical and supplementary angles, and then compare them, the corresponding, the same side interior, etc., until you can figure out which ones are actually congruent and which lines are actually parallel. So pause here, try the last few problems, and be ready to answer your answers when you're done. Good luck!